Picture a caveman in your head for a second. Chances are, somewhere in that mental image, there's a smell attached to it. Matted hair, dirt-caked skin, a general sense of unwashed filth. It's such a reliable part of the stereotype that smells like a caveman barely needs explaining. But that image deserves a closer look because your ancient ancestors' bodies were doing something surprisingly sophisticated with sweat, and the real story is a lot more interesting than they were just gross. Start with a strange fact about your own body. You are, among mammals, unusually hairless and unusually good at sweating. Paleoanthropologist Nina Jablonski has spent much of her career studying exactly why. Her research argues that losing most of our body hair and gaining an extremely dense covering of a specific kind of sweat gland, called Eccrine glands, evolved together as a single package for one very practical reason: cooling down. Early humans were foraging and pursuing prey across hot open savanna, sometimes for hours at a stretch. And a body that can dump heat efficiently through evaporating sweat has a massive endurance advantage over a body covered in insulating fur. This wasn't an accident or a design flaw. It was very possibly one of the specific adaptations that let your ancestors outsurvive animals that were faster, stronger, and better armed simply by outlasting them in the heat. Compare that to almost any other large mammal on that same savanna. A lion or an antelope can't sweat its way through heat the way a human can. It has to pant, or slow down, or find shade, and wait out the hottest part of the day. A human covered in dense fur would face that same problem. So somewhere in deep human prehistory, the ancestors who happened to have slightly less hair and slightly more of these particular sweat glands could keep moving through conditions that forced other animals to stop, and that advantage generation after generation compounded into the strange, nearly hairless, heavily sweating body plan every human alive today still carries around. Here's the detail that changes the whole picture. Eccrine sweat, the kind covering almost your entire body, is mostly just water and salt. It's nearly odorless on its own. The sweat glands actually responsible for smell are a different type entirely, called apocrine glands, and they're concentrated in a much smaller set of locations: the armpits, the groin. Apocrine sweat is thicker, oilier, and when it mixes with the bacteria that live naturally on human skin, that combination is what produces actual body odor. So there was never a version of a human body that smelled like nothing. Even a perfectly healthy, perfectly evolved ancestor sweating exactly the way their body was built to sweat was going to have some odor coming from those specific spots. That's not a hygiene failure. That's just what apocrine glands and skin bacteria do together, and they've been doing it for a very long time. It's also worth noticing where apocrine glands actually sit on the body. The armpits and groin, both places covered in hair even on an otherwise fairly hairless human. Body hair is unusually good at trapping the oils apocrine glands release and holding them close to the skin, giving bacteria more surface area and more time to work, which is part of why odor concentrates so heavily in exactly those spots and nowhere else. It's a small, easy-to-miss detail, but it means the two halves of this story, the hairless for cooling half and the smelly apocrine spots half, aren't really in tension with each other. They're describing the same evolved body from two different angles. There's an even stranger twist hiding in the genetics of body odor, and it comes from a 2006 study led by geneticist Koichiro Yoshira. His team found a single genetic switch, a tiny variation in a gene called ABCC11 that determines two things at once: whether a person's earwax is wet and amber-colored or dry and flaky, and, separately, how strong that person's underarm body odor tends to be. The dry earwax lower odor version of this gene is common across East Asia and rare almost everywhere else. And the pattern in the DNA suggests it spread unusually fast, the genetic signature of something called strong recent positive selection. In plain terms, body odor intensity itself isn't just about how often anyone bathes. It's partly written directly into different populations' DNA, and has been for a long time, quietly, underneath everything else going on in human history. So if the body itself wasn't the problem, what about behavior? Did ancient humans actually do anything about how they smelled, or just let apocrine glands run their course? The evidence suggests they weren't indifferent to it. And some of that evidence comes from a behavior that looks social on the surface, but does real hygienic work underneath. Evolutionary psychologist Robin Dunbar has written extensively about social grooming among primates, the picking through fur behavior that dominates a huge share of daily time in chimp and monkey groups. Its most obvious job is bonding and maintaining alliances, but it's also quite literally pest and dirt removal, hands physically going through hair and skin to pull out parasites and debris. Early humans almost certainly inherited some version of that same instinct before it eventually got replaced, at least in part, by language and conversation as the more efficient way to maintain the same social bonds. The habit of physically tending to another person's hair and skin didn't disappear so much as get supplemented. Early human sites also cluster heavily near reliable water sources, for drinking and food, certainly, but regular access to water also means regular opportunity for washing, whether or not anyone called it that. There is also a genuinely clever piece of evidence buried in something that has nothing to do with soap at all: lice. A 2003 genetic study led by Mark Stoneking, Ralph Kittler, and Manfred Kaiser compared the DNA of human head lice and human body lice, the kind that specifically lives in clothing rather than hair, and calculated when the two split into separate populations. Their answer lands somewhere between about 72,000 and 170,000 years ago, which the researchers argue marks roughly when humans started regularly wearing clothes. Clothing worn for long stretches without washing is exactly the kind of environment a new parasite species could evolve to exploit. In other words, buried in a genetic clock ticking inside a louse is a hint that once clothing entered the picture, at least some of it went a while between washes, and eventually cleaning became something people did on purpose, with a recipe. The oldest known soap-making instructions come from Babylonian clay tablets, roughly 4,200 years old, describing boiling water, wood ash, and oil together, the exact same basic chemistry, an alkaline substance reacting with fat that still makes soap work today. Worth noting, that particular recipe was mainly used for cleaning wool cloth, not bodies, but it shows people had already worked out, through pure trial and error, how to deliberately break down grease and dirt using ordinary materials sitting around a household thousands of years before anyone understood the chemistry behind why it worked. Put all of that together, and the honest answer to did ancient humans smell bad is more nuanced than the stereotype allows. Probably about as much as you would doing hard physical work outdoors all day with no deodorant, which is to say, yes, some odor, coming from exactly the same apocrine glands yours has right now, but not some uniquely filthy subhuman condition. Their bodies were arguably better engineered for the heat than yours is. Their genetics in some populations may have made them less prone to strong odor than others. And they very likely had at least some rough concept of washing, long before anyone wrote down a recipe for how. The caveman-stench stereotype says less about what ancient humans actually smelled like, and more about a much later, much more recent obsession with never smelling like a body at all.